Hi, this is the AQA Summer 2017 GCSE Mathematics Higher Paper 1, the non-calculator paper. In this video, I'm going to go through the questions from this exam paper. Question number 1. Simplify 2 to the power of 5 times 2 cubed. So 2 to the power of 5 is 2 times 2 times 2 times 2 times 2. So 1, 2, 3, 4, 5 2's multiplied together. 2 cubed is going to be 2 times 2 times 2, and we are multiplying these together. So altogether there are 1, 2, 3, 4, 5, 6, 7, 8 2's that are being multiplied together. So that gives us 2 to the power of 8. Question 2 says circle the reason why these triangles are congruent. So congruent means why are these triangles exactly the same as each other? Well, on this one we've got an angle that we know and a side that we know and another angle that we know, and the side is in between the two angles that we know. And over here we've got an angle that we know, 32 degrees, same as that one, and a side that we know, 7 centimeters, the same as that one, and an angle that we know, 90 degrees, the same as that one. And we've got again an angle, two angles and a side in between that we know. And because those two angles are the same as each other and the side in between is the same, therefore they're going to be congruent. And we've got this angle, side in between angle that tells us that they're congruent with one another. Okay, question number 3. Which of these is a geometric progression? So geometric progression means that it has what we call a common ratio, so a number that's been multiplied to get to the next term. So if we go through each of these, we should be able to spot on this one here we have what we call a common ratio, because to get from the first term to the second term and multiply by 3, and then multiply by 3 again to get to the next term, multiply by 3, and then multiply by 3 again. So this is going to be our geometric progression. None of the other ones have that property where they have a common ratio. Okay, question number 4. A to B is equal to 4 to 3, but we want to circle the correct statement. So let's have a look. B is 4/7 of A. So if I find 4/7 of A, do I get B? So 4 divided by 7 multiplied by 4 does not give me 3, so it's not going to be that one. B is 3/7 of A. If I find 3/7 of A, do I get B? So 4 divided by 7 multiplied by 3. That's not going to give me that value there, so that's not going to be true. B is 4/3 of A. So if I take this number 4, divide it by 3 and multiply it by 4, do I get 3? No, I don't. B is 3/4 of A. So if I divide that by 4, I get 1, and times that by 3, I get 3, and I do in fact get A. And we can see that this value of B is in fact 3/4 of this value of A. So we're going to go with this one over here. Okay, question 5 says write 36 as a product of prime factors. We want to give our answer in index form. So we can draw a factor tree for this. So I'm going to start with 36, and we're going to split that up into two numbers that give us a product of 36, and that might be 4 and 9. And then I want two numbers that give me a product of 4, and that's going to be 2 and 2. Both of them are prime numbers, so I'm going to put a circle around those. And then 9, we've got 3 times 3, and again they're both prime numbers, so I'll put a circle around those. So that means that we've got 2 times 2 times 3 times 3. We want to give our answer in index form, so I'm going to write that as 36 is equal to 2 squared times 3 squared. And we could just have a final check. 2 squared is 4, 3 squared is 9, 4 times 9 does in fact give us 36, and we should be happy.